Hello everyone, I am Varsha and this research paper presentation is done by Jatin and me. Our research paper title is Beyond Accuracy, Behavioral Testing of NLP Models with Checklist. These are the contents of the presentation. One of the primary goals of training NLP models in a generalization. Since testing in the wild is expensive and does not allow for fast iterations, the standard paradigm for evaluation is using train validation test splits to estimate the accuracy of the model, including the use of leaderboards to track progress on a task. Behavioral testing, also known as black box testing, is concerned with testing different capabilities of a system by validating the input-output behavior without any knowledge of the internal structure. Checklist guides users in what to test by providing a list of linguistic capabilities which are applicable to most tasks. In this work, we propose a checklist, a new evaluation methodology, and an accompanying tool for comprehensive behavioral testing of NLP models. Let us have a look at an example. In Figure 1, potential tests are structured as a conceptual matrix with capabilities as rows and test types as columns. We generate a large number of simple examples filling in a template. I, negation, postverb, the thing, with pre-built lexicons and compute the model's failure rate on such examples. Checklist is easy to use and provides immediate value. In a user study, the team responsible for a commercial sentiment analysis model discovered many new and actionable bugs in their own model, even though it had been extensively tested and used by customers. We can divide checklist into three categories: capabilities, test types, and generating test cases at scale. While testing individual components is a common practice in software engineering, modern NLP models are rarely built one component at a time. We suggest that users consider at least the following capabilities: vocabulary plus POS, taxonomy, robustness, NER, fairness, temporal, negation, co-reference, semantic role labeling, and logic. A minimum functionality test inspired by unit tests in software engineering is a collection of simple examples and labels to check a behavior within a capability. An invariance test is when we apply label preserving perturbations to inputs and expect the model prediction to remain the same. A directional expectation test is similar, except that the label is expected to change in a certain way. To test any model, we need large number of test cases. One can create test cases from scratch or by perturbing an existing dataset. We further divide into templates, expanding templates, and open source. An example to explain template is I didn't love the food with a template. I, negation, postverb, the thing, where negation equals didn't, can't say, I, etc. Postverb is love, like, etc. Thing is food, flight, service, etc. While templates help scale up test case generation, they still rely on the user's creativity to create fill-in values for each placeholder. Example, I really mask the flight. Yields enjoyed, liked, loved, regret. They release checklist on GitHub and it is open source. In addition to templating features and mask language model suggestions, it contains various visualizations, abstractions for writing test expectations and perturbations. To test SOTA models with checklist, sentiment analysis models like Microsoft's Text Analytics, Google Cloud's Natural Language, and Amazon's Comprehend are used. Social media is used for sentiment analysis. Tests are created for a broad range of capabilities having a subset with high failure rates. The outcome is Google and Amazon fail on neutral sentences. Google failed on non-neutral sanity checks. None of the models does well in tests for the temporal, negation, and SRL capabilities. Commercial models do not fail simple fairness sanity checks, always predicting them as neutral. The absence of test failure does not imply that these models are fair, just that they're not unfair enough to fail these simple tests. Failure always predicts negative when protected is black, atheist, gay, and lesbian, while predicting positive for Asian, straight, etc. Failure and Robust did better than all commercial models on almost every other test. The failure rates for the NER tests indicate that these models were relying on shortcuts. The checklist was presented, and the team was asked to use the methodology to test their own model. The checklist was presented without presenting the tests they had already created. They proposed new capabilities for testing, example, handling different lens and sentiments that depend on implicit expectations. The checklist proved to be very helpful. They discovered many previously unknown bugs, which they planned to fix in the next model iteration. A user study was conducted to further evaluate different subsets of checklists in a more controlled environment and to verify if even users with no previous experience in a task could gain insights and find bugs in the model. 18 experienced participants were recruited to test failure fine tune on QQP. Participants were separated equally into three conditions. In unaided, they weren't given any further instructions, simulating the current status quo for commercial systems. In CAP only, they were provided short descriptions of the capabilities. In CAP plus template, they were provided further with the template and fill-in tools. At the end of the experiment, users were asked to evaluate the severity of the failures they observed on each particular test on a 5-point scale. This is a summary of the tabular test. Users with checklist discovered much more severe problems in the model than users in the control condition. The study results were encouraging. Users without prior experience were able to find significant bugs in the SOTA model in only 2 hours. Thus, we can conclude that while useful, accuracy on benchmark is not sufficient for evaluating NLP models. Adopting principles from behavioral testing and software engineering, uh, they were proposed checklist, a model agnostic and task agnostic testing methodology that tests individual capabilities of the models using 3 different test types. Further, checklist reveals critical bugs in commercial systems developed by large software companies, indicating that it complements current practices well. The user studies indicate that checklist is easy to learn and use and helpful both for expert users who have tested their models at length and for practitioners with little experience in a task. The tests presented in this paper are open to checklist, open source release, and can easily be incorporated into existing benchmarks. More importantly, the abstractions and tools in checklists can be used to collectively create more exhaustive test suites for a variety of tasks. Thank you.